our goal again today is to be simplifying these rational expressions, and rational rational means what? Rational means fraction. Definite fraction. And the other thing that we talked about that's going to be super important to do is because we are now working with things with fractions, if you have a variable in the denominator at any point, you need to state what? Restriction. Because it's important. Fractions, you cannot have what in the denominator. A zero. If they equal those restriction values, you are undefined in your problem. Alright, so for our warm-up today, we started factoring, we put into a rational expression, we reduced it, we talked about why the restrictions work for a couple of years, and I'll you'll be so excited. Okay. So let's start with number one. Again, the first thing that you should always look for when you are simplifying is you should look to see if it factors and then reduce it. I do have a second rule that I always like to write in here as well. Second rule is if something is written twice, but they write it like this, x plus 3 quantity in squares, I'm actually going to encourage you, instead of writing x plus 3 quantity squared, to write x plus 3 times x plus 3. Yeah. And that way you can see if one of those can cross off and one of those don't have to cross off. You can see what's up. So those are the two basic rules that we started with today. Alright, so let's talk about number one. Can anything reduce in the numerator? Can anything reduce GCF? Yes. Anything in the bottom? What is it? 8. Okay, so from the top I still have 2, from the bottom I have 8 times x plus 2. Okay, now look at the numerator and look at the denominator. I have 2 constants. I can believe it. 2 and 8. They reduce? What do they reduce to? 1 and 4. Then cross this guy off and write 1. Cross this guy off and write 4. And that's pretty much all I'm going to do to this problem. I'm going to write it. A lot of times I find I don't want to distribute it back. I want to leave it like this, because later on we can do lots more stuff with it like this. So this is the first part of our answer. And then what's super important is what can x not equal? Negative 2. So you're going to write next to it, x cannot equal negative 2. There's just all of it. You can see one right now. Number 2. Can anything factor in the numerator? No. How about the denominator? Yeah, 2 times x squared minus 1 squared. 2 squared. These are squares. So this is 2 squared. So this becomes x minus 2, x minus 2. What do you notice? X minus 2 comes out. Yeah. Cross off, you write 1 in the top. There's our answer. 1 all over x plus 2. Now, although we cross it off, it's really important to go back here as well. We needed 2 things that x cannot equal. 0. It can equal 0, because 0 minus 2 is negative 2. Oh, one. Oh, I'll just put the problem on this. Wait, but we did it 0 and 8. We did it. By 2 and 8. So So I pull out 8 first. 16, pull off 8. What is 8 times 2? Yeah, I know, but why? Oh, key is that. Why did I only reduce this concept? Why did I not do anything inside this? That's not part of it. Not part of what? Not part of the concept? What else? These are my parentheses. You have to do the whole thing parentheses, or you can't do anything else. So, like you always say, you always, so, you say, now I add plus 30, you make it, on the inside of the parentheses, plus 38, 9, y, and then you do parentheses, 36, you know, that, and then you do 9, and then you do, okay. But then the 2 will be able to simplify it. No. If it can't be simplified, circle transfer. Not an issue. Or right cannot be simplified. Okay, let's talk about number 3. 2x minus 10. Can that be factor? Yeah. By 2. Leaving inside 2 times x minus 5. How about the denominator? 3. Leaving x minus. Okay, what's your constant? Doing great. Anything you do? No. X minus 5 and x minus 5? Sort of. Are they exactly the same, guys? No. So what's your answer? This is it. Alright, the only other thing I want to do to this problem is right here. What can x not equal? All I'm concerned about is the denominator. Pretty cool. Okay, number 4. Up in the numerator. That's insurance x squared. X squared. GCF of x squared. X squared leaving inside x plus 7. In the denominator, I know 3 terms, no GCF. So I look in the front, I see x and x. I look in the back, 1 and 2 and 7. Alright, and which of those is the top?
2 7 minus
Okay, x minus 2 and x plus 7. X plus 7. So our final answer, I think, is minus 1. Take it up to this side right here. It's going to be x squared all over x minus 2. And then I'm going to go back to this one right here. There's 2 things that x can equal. This guy, 2, this guy, and this guy. Okay, here we go. Number 5. Number 5, how many terms are up top? 4. 4. We'll do it 4 times. Root it, that's right. This is plus 5. Now, before we start, grouping doesn't necessarily have to be in proper order, but I've got a 5 and a 15. It looks like those kind of belong together, 5 and 15. And then I've got an xy and a 3y. Those both have y's. Do they look like they go together? Yes. Okay. Did you put in a plus sign? Plus sign. I'm going to just use this. Both of these are negative, and particularly the lead coefficient is a negative, therefore we're going to take out a negative. What's the chance? Y. So you need to take positive x and positive. So the match now? So far we've only come to divide. And what we're saying divide by 2, we can factor out 2. Take out 2. So you can see this. Oh, you cut out all. But not all of them. Let me finish this off. 5 minus y times x plus 3 all over 2 times x plus 3. And now top up the x plus 3. The final answer is going to be 5 minus y over 2. So really important, although we crossed it off, what can x not equal to 5? Yes, go for it, Paul. Careful with those words, I know what you're saying there. So the last one that I have for you, in the numerator I have 2 terms. Now what do you see that? What are we looking for? Perfect. Perfect squares. Perfect. Which one do you see? Perfect is greater than 2. X2 plus 1. 2 people make the 8, right? So what's the pattern?
Oh.
What's the pattern? What drops down? X and just like that? Plus 2. So exactly what it looks like without the 2 paper. And then how many times are you going to write it out? X, 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 2, 2, 2. So you go X and X, X and 2, and 2 and 2. Write it down. X squared, 2x, and 4. Not too many symbols. What are the symbols going to be? Like this. Found you watching? No. So you turn down? No. Also, what part's wrong? This. So this is our answer, but what if X not equal to? Alright, so then our whole goal today is to factor things out, simplify, and save your restrictions. So you guys have this note right here written down about something squared for that twice. That is the goal today. We took this off here, and we'll get